Hello everyone and welcome to the public space. Today we are talking physics, we are talking light. I remember my high school teacher in physics telling me, we don't know what light is. Ask physicists, they have no clue. And so we'll talk with Bill Gaede, who has his own hypothesis of light and gravity, and we'll see what that is. It's called the rope hypothesis. I can't wait to hear about it. Bill, how are you doing today?
Oh, I'm doing pretty good.
All
but
right.
you're right.
So
they don't know what light is. Yes.
Before we jump into the physics subjects, a few news for our audience. Sargon of Akkad on Patreon has been banned from Patreon. We still don't know why. It's probably that some people who are opposed to his politics have just quoted his historical jokes, and they've collected for years everything he's been saying, and they've made it look like he was doing hate speech. Too bad, Sargon is gone from Patreon. The censorship continues. I also hear that James Alsop is banned from Patreon. We're still surviving. I can't believe we're surviving in this context. Also, my book is going very well. It's been there since 3 days. It is #1 new release in biology on Amazon. Both the paperback and the electronic version also has reached #1 new release in biology. Buy it now. Leave those 5-star reviews. It really helps. It helps the algorithm. Let's get this book known. Let's get this book some exposure. It is a book called The Revolutionary Phenotype, and it is about the emergence of life and the dangers of genetic modification. Humanity will either read this book or we're all gonna die. Bill, let's talk about physics. What is physics?
Well, that's a good question. I think the problem we have today is that we've lost track of what physics is or what it was supposed to be. And today it's called mathematical physics. If you go to the university, you study not physics, you study something called mathematical physics. And I'm saying mathematics has nothing to do with physics, and physics has nothing to do with mathematics. And that's where people start throwing the rotten eggs at me and say, are you crazy? What are you saying? You know? And this whole thing started really in the 17th century with the so-called scientific revolution. People such as, starting with Galileo and people like him, you know, in the early part, and then ending with people like Christian Huygens and Newton towards the end of that century. And what they said, look, you need to run an experiment, and you need to test the theory, okay? And how do you test it? Well, you test it doing some kind of experiment, and then you try to apply some kind of math to it. You try to put what you observed in some form of equation, okay? And so what has developed from there after 400 years is that today we do everything with math, and people say, well, that's science because math is objective, right? You have an equation, force equals mass times acceleration. It's an objective relation, right, between these two sides of the equal sign. And so that sounds quite rational to people. And people say, well, yeah, that's physics, that's science. And I'm saying that has nothing to do with science. That is a description. And science is not describing. Science is explaining. I have not yet explained anything. And I'll give you a good example. You go to the show, okay, and you watch the magician cut the lady in half, okay? So he saws her. Curtains close, curtains open, and the lady is in one piece. She bows to the crowd. And so you ask the mathematician next to you, and you say, how did he do that? And he says, oh, very simple. And here the key word is the word how. Are we talking about a description or an explanation? How? And he says, well, the lady was in one piece. He cut her into 2 pieces. He took 20 strokes of the saw. He did it in 10 seconds. And then she appeared on the stage in one piece. That's what happened. Well, I was asking, how did he do the trick? That's what I want to know. And that's the difference between math and physics. Math can give you quantitative relationships, but math has no power or authority to tell you to give you a physical interpretation, to tell you what happened, how it happened, what the cause, what the mechanism is. And that's where we separate physics from math.
Well, on that point, isn't it possible that you are a little bit strawmanning the people who do physics? Because my feeling is that most people in physics understand this. Of course, locally, they may act like math is the thing. Because, of course, looking at equations in physics has been extremely productive. It has led to relativity. It has led to frameworks that have predicted stuff that we wouldn't have predicted otherwise. I mean, from Newton to Einstein and even after with quantum physics. So is it possible that essentially physicists and I understand this? We understand that math is not the final language of the universe. Of course, I know there's one TED conference out there where some guy claims that math is the language of the universe. But the idea is that math is a representational system that can actually represent anything, potentially. Math could be made in various ways as to fit the universe. And I think that's how most scientists approach math.
Well, this is the issue. The issue is that I'm talking about a physical interpretation. Okay? The math is okay. I have no problem with the math. I don't have any problem with the equations. I'm saying that has nothing to do with physics. Physics is a physical interpretation, a qualitative explanation of how something happened, what the mechanism was. How does quantum, how does relativity explain things today after 400 years? Well, these are the words they use. They use words such as energy. They use words such as mass. They use words such as field and time and force. These are not physical objects. I cannot say rationally, I cannot say I transferred energy, because there is no physical object called energy. I can say I transferred a dog, I transferred a rock, I transferred a tree. Those are objects. I cannot say I transferred love. I can transfer a heart, but I cannot transfer love. And that's what they're saying when they say they transfer energy, or that they moved a mass, or that the field expanded. They treat these concepts as physical objects. And that's why we don't have a physical interpretation for the equations. I have no problem with the equations. I'm saying that the physical interpretations that they give are all bogus, 150% of them.
Sorry, I was muted. So the problem is that thinking of things like objects, it does bring some assumptions. I mean, to talk of objects, you're already talking of a space in which these objects are embedded. And so not everything in physics has to be objects, because objects are bound to be a kind of subset of what the universe is about. If we are to talk about these objects producing forces on each other, then we're really modeling how these objects interact with each other in a space with properties of speed, of Newtonian mechanics. If we are to care about how these objects spread across the universe during the Big Bang, from the Big Bang to here, then we need relativity, and we need these equations that bend space-time. It is clear that the realities that we invoke in physics must invoke something else than an object, precisely because physics is about describing the universe in which these objects can exist as part of a subset of what can exist.
Well, you said physics is about describing. You also said, I'll mention three statements you just made. One was the one at the beginning of your show. The first one you said, we don't know what light is. That doesn't come from me. That comes from your teacher, who apparently was a physics teacher. Then you said, we need to describe, okay? And I don't know what the third one was, but not so important. This is the issue. The issue is that, let's begin at the beginning, like the Bible. In the beginning, do we need a physical object to do physics? Can we do physics without any physical object?
Well, in principle, you could have a model that explains object without referring to objects as anything else than a secondary effect of that equation. And I think that's essentially what modern physics theories are. Mass and the idea of objects is just a manifestation. If you look at quantum Darwinism, for example, mass and the classical physics properties are simply an emergent property of an underlying system. So yes, I would say we can have a physics that doesn't specifically mention objects, but where objects and visible atoms emerge as a consequence of the properties that we give to lower levels. I guess we could call them lower level objects, but they are not objects in the sense that they could be seen in the universe, but they are objects of the encompassing theory. So when quantum Darwinism says, all right, there's a competing set of information systems within the quantum universe, and as a consequence of this competing set of entities, there is an atom emerging here or a particle emerging here. Or when quantum field theory tells you the same and explains it in terms of the activation of certain states of certain fields or certain interactions between certain fields, I believe that those are theories that are objectless, if you will, but that create object in the end.
I guess you didn't answer my question, so I'll ask it one more time. There's nothing, absolutely nothing in the universe. Can we have a phenomenon occurring without objects? First of all, is there anything happening?
You can have systems in which things occur without objects. For example, the prime numbers, they emerge from Euclidean geometry, yet there is no object in Euclidean geometry, or there is no object, at least in numbers theory. I mean, unless you want to call the numbers objects.
What is an object according to you? Because that, I think that we're not communicating what an object is.
Okay, well, I've assumed that you are bringing object as physical matter that has mass. Is that it?
No.
Okay, what is an object for you then?
So this is where we start, because I say that the definition of the word object destroys all religion and destroys all of mathematical physics. That's my argument. And I'm saying that for in 10,000 years, no one has defined the word object, and you absolutely need an object to do physics. You cannot do physics without an object. There's nothing happening without an object. You can describe and put an equation, but for a physical occurrence to happen, for something to happen, for the moon to have a hole in it, because an asteroid hit it, you need objects. You can't have the hole in the moon without an object. You need an object to do physics. And an object is not that which has mass. It's not that which we can touch or see. It's not that which has volume. An object is that which has shape.
An object is that which has shape.
Yeah. So now, just like you said, a number is not shape. So I can't use numbers. I need to do physics with shapes. I need to make a movie of my theory, of my explanation for a cause or mechanism. If I have to tell you, for example, how a car works, I can make a movie of the whole thing, because you can see every part. You can see the gas going through the tube, going to the carburetor, going to the pistons, and so on, and the car moves forward. You can understand my theory of how a car works simply by looking at the movie. How can we do this with space-time when the word time is a concept? What are we bending? How do we explain gravity with space-time if space-time is not a physical object? What physical interpretation is that? How can I say that gravity is the warpage of space-time when we're talking about a concept? Can we bend love and I say gravity is the bending of love?
Well, I don't take objection to concepts, because the idea of shape relies on the assumption that there is a physical space in which this shape manifests. For example, would you say then that that light in general, would you say that waves are objects?
No, of course not. There's no such thing as a wave. There's no such thing as space-time. That's the point. You need to have something that has shape. And if you look at the transverse wave that they use in quantum mechanics and in wave theory, what you have is vectors. And a vector is simply an object that has magnitude and direction. So all these little lines that you see when they show you this transverse wave. Those are just vectors. Those are mathematical concepts. A wave is not a physical object.
Well,
Water
the thing is, I find this whole concept that,
but the wave, no.
I'm actually willing to follow you on this line of thought. So, okay, physics is about shapes. This is what you're saying, but it seems to me like an assumption. Like you could be in a universe where other things matter, where the gaps between the primes matter more than anything, and that is the subject of your physics. Shape is just an emergent property of any systems of space in which you have the possibility of having states of yes or no. So if there is some plastic at this position in the universe, then of course the emergent property of that will be shape. But that is nothing else than stating the fact that space exists.
Let me give you an example. A couple of examples. I'll let you choose. Okay, you got a choice here.
All right.
A brick goes through the window and breaks the window, and the brick falls on the floor. Okay, so I come home and ask the person, how did the window break? What is he going to tell me? Is he going to say, well, there was a force with a lot of energy, and it went, and all this mass went through the window? Or is he going to say, look, a brick went through the window and just broke it? I mean, how do you explain something? Do you use concepts such as force, energy, and mass to explain a broken window? And is that
you could. That's the point. You could. You could say that there were atoms in the brick, and these atoms, they had a magnetic force that was negative on their outer shell. And this magnetic force pushed into the atoms of the window and therefore cracked it and eventually broke it such that the atoms of the window were not attached to each other anymore. You could make it in terms of force. The idea is that force is not mutually exclusive with the concept of shapes and objects existing.
I don't need that. If I want to explain how I pull a bucket of water with a pulley, I say, look, the rope is tied around the pulley. I pull on the rope and it lifts the bucket. I don't need the word force. I don't need the word energy. I don't need any mathematics to explain that physical phenomenon. I do not need any mathematics. I don't need the words energy. I don't need the word time. All I need to show is how I pulled the bucket up. And the same way, if I broke a window, I have to explain, look, I threw a rock and that's how the window broke. I don't need the word energy. I don't need the word time. I don't need the word mass. I don't need any of the garbage of mathematics. None of it.
Well, it does seem that in your use of the word pull, there are assumptions underlying pull. The idea of pulling works if the object is sticking to itself enough that it remains an object once you pull it. And if you pull it in the vertical direction, then yes, you will be countering some force of gravity. You may not want to call it force, and I'm willing to follow you on any crazy land on this. I'm willing to explore anything, but you're going to have to face something that I call gravity.
Yes. And just one more thing. See, I can make a movie. I don't have to use the word pull. I can show the extraterrestrial alien, right? I can show how I pulled the bucket up. I just show him the movie. I said, I pull here. In other words, I show the movie of guy pulling, the rope going around the pulley and the bucket coming up. I don't need the word energy. Nothing. I can't even put it on the screen. All I have to show is the mechanism. And that's what we're missing with physics today. No one can tell you, here, look, I have 2 magnets here. Can you see that? Okay.
Okay.
And how do we do that magic? Well, there's not a single person on earth in the last 10,000 years can explain how this magic happens. Why? Because they're using concepts. No one can tell you how a magnet attracts another. No one can tell you how this pen, why it falls to the floor. The question that they have to answer is, what physical entity comes in contact with the skin of the pen? Otherwise, we don't have an explanation. You cannot say, oh, it fell because the mass was attracted by gravity. That's not an explanation. An explanation is, tell me what physical object came in contact with the skin of the pen. That's how we explain it in physics. Otherwise, we're doing math.
You're totally right on this. We don't have a ultimate explanation for gravity. for magnetism, we explain these as forces. And we describe these for now, we quantify these. So we can say exactly how much time the pen will take to reach the Earth. We can say that it would fall differently on a different planet. That's what we know. So you're right on this. We don't have a fundamental explanation of these phenomena and a unified theory of everything, if you will. So I'm following you on this one. Where does that bring us?
Okay, that brings us to the rope model. See, the rope, here's a rope. This is a rope, okay? And this is a physical object. A wave is not a physical object. In fact, a wave is a cross-section of the rope. If you take this rope, you cut it in half, then you'll see what a wave is. And I'm saying that a rope does give us an idea of how gravity, how light, how electricity, how magnetism work. Why? Because I'm saying that all atoms in the universe are interconnected, whereas quantum mechanics and mathematical physics in general say that all particles are discrete particles. They have nothing, you know, they're all just floating around in space, and one particle has nothing to do with the other particle. Each one is an individual island. I'm saying that all atoms in the universe are interconnected. Now with that, we can explain action at a distance, because otherwise, if we don't have some kind of elongated object between objects, we cannot explain action at a distance. What are we going to put between two objects? Let's say here I have two balls, for example. Look, I have two balls, right?
Okay.
Here.
Yep. There.
Here, quantum says that, you know, this particle can affect this particle from a distance. Okay. And the question then becomes, are we not going to put something between these two balls? We're saying this one affects this one, but there's nothing in between them. That's magic. That's putting spirits in between the two balls. If instead we have some kind of rope, some kind of elongated mechanism, right? Now we can explain how this one affects that one. And so I'm saying that the invisible entities that are between two magnets, which do entanglement, which is how one particle affects another one at a distance, can only be done if you have some kind of physical mediator, an invisible physical mediator.
All right. So let's say we're looking at planet Earth and we're looking at the moon. Planet Earth is attracting the moon toward itself such that the moon doesn't go away. And there are various ways in which you could explain this. The Newtonian mechanics was saying, well, there's a force. There's a force that pushes the moon toward the Earth. Quantum physics invokes a hypothetical particle, which would be the graviton. You are saying the graviton theory, what do you think about it? That it doesn't make sense? That we won't ever find a graviton?
Yeah, of course, because and here again, once I say here's the Earth. Let's see if I get it right. This is the Earth, okay?
Yep.
And this is the moon, okay? Now, is the Earth throwing gravitons, particles at it? If you throw particles at a dog, do you attract them? No, you can only push them away. The particles can only, when you throw bullets, all you can do is push away something. You can never attract using bullets.
Well,
and that's the problem with,
let me just point out, to state that, you are bringing an assumption, which is that these particles work in the same way that Newtonian particles work, by carrying energy, inertia energy, and the properties of speed, and how it's transmitted between objects that collide each other, right?
Yeah, in other words, if I throw something outwards, I cannot bring that, whatever it hits, inwards. I cannot shoot an arrow and bring the target towards me. And that's the bottom line.
Those are assumptions that rely on stating that these particles work like classical objects that would carry energy in their speed.
Yeah, because otherwise we have to use what quantum uses, which is magic. They're saying we don't understand quantum, but this is how what we see in the lab, that the particle goes out and attracts something inwards. Of course, because they have no explanation for it. That's a mathematical thing where they say, well, we're going to introduce negative force or negative momentum. So we throw the particle out that delivers negative momentum and attracts the target inwards. That's magic. That's nonsense. Obviously, it's a bogus explanation. On the other hand, if the gun and the target, or the arrow, the bow, I guess, the bow in the air and the target are connected, now we can explain how the bow attracts the target or how the gun attacks the target, because they have to have some mediator in there.
All right. I'm interested in getting there, but I just want to take the defense of my physics friends and say that in stating the graviton, they're not invoking magic. They're making a prediction. It's like, it would be awesome to find the graviton. Wouldn't you acknowledge that it would be awesome that someone predicted that there would be a particle and that we would eventually find it? It's not necessarily magic. It is hypothesis about what we may find if our calculations are correct.
Yeah, but keep in mind what you're saying. You're saying that you're looking for a particle, again, that goes outwards and pulls something inwards. How can you rationalize that?
That's the fascinating thing, is that we may be faced with a particle that does carry negative momentum. But I'm not stuck on this hypothesis. I think it would be awesome. I think that alternative hypotheses are also awesome. Before we move to your rope hypothesis and how that works there, let's just talk about relativity. Because on the other end, you have quantum physics saying, well, it could be a graviton. You also have relativity, which says it could be a curvature of space-time.
Yeah, and can anyone draw that? Can anyone make a movie of how four-dimensional something, whatever that is, including time, which is a concept, how you can bend it? How do you bend time? I mean,
you cannot see that in your head, because bending a three-dimensional space is like impossible in your head. But we can see it in 2 dimensions and imagine how that would look like in 3 dimensions. It's simply mathematics that tell you that no, the universe is not made of squares and grids that are perfectly aligned. Like, do you recognize that your hypothesis relies on this assumption, at least, that you are constructing a grid of perfectly aligned squares that never curve, that never change? Your hypothesis does rely on this assumption, right?
No, my assumptions involve all objects, only objects that are 3D objects. I do not use squares. I do not use four-dimensional, unimaginable four-dimensional entities, which are really concepts. And that's why we have to use objects. As long as we use objects, we're doing physics. As soon as we use concepts, we're not doing physics anymore. You can't bend space-time because space-time is a concept. You can't send a wave because a wave is a concept. You can't send a zero-dimensional particle, which is actually a field, because those are concepts, and so on down the line. The reason they had to come up with things like negative momentum or warpage of space-time is because they could not give a rational explanation. They had to use concepts. With concepts, you can do anything. You can say, yeah, love moves mountains. Yeah, go try it. I mean, make the movie of love moving mountains. What are you going to put for love? And what are you going to put for a negative momentum? Well, I mean, how do I make a movie with negative momentum? I just make it by magic wand?
Well, it seems that your energy did convince some people on the chat, because they are saying JF is an Einstein cock. All right. I don't mind being insulted. I am an Einstein cock. I don't think that Einstein's relativity necessarily is the final words of physics. But I think that, I mean, do you recognize that it predicts, for example, I hear often that it predicts the trajectory of Mercury better than Newtonian mechanics?
It does, but we don't give a damn about it, because predictions are not part of science. Science, rational explanations. Prediction has to do with the future. In science, we do not predict. That's part of the mathematical world. Why? Because they say, look, here's an equation. And with this equation, I can predict. You know, I can apply it over and over and again in the future. We don't care about that. That's got nothing to do with science. Science is explain what happened. It's always in the past. You got to explain a phenomenon. And what these people have done is introduce the word prediction, which has nothing to do with science. That's the issue. So we don't care if Einstein's equation predicts better the revolution of Mercury around the sun better than Newton's. It's got nothing to do with science. Absolutely nothing to do with science. Science, you got to explain why Mercury doesn't fly out of the solar system. That's what they need to explain. And if they're going to say, look, it's space-time, the warpage of space-time, well, what is space-time? Please draw it on the board. And they say, no, I'll give you a two-dimensional version of it. Well, now they're cheating. Now they're just cheating. They're saying, look, I want you to think about this way. Let me explain it. No, I don't want you to explain. I don't want you to think. I want you to draw it. If you can draw space-time, then I'll accept it. Otherwise, it doesn't belong to physics. There's no four-dimensional object in the universe. This is madness of the mathematicians who had to use four coordinates, which they call dimensions. They're coordinates. And they're saying, look, we can locate a point within space-time with four coordinates. And now they start bending the coordinates, which is a concept. They're saying, look, if we bend these coordinates, we got gravity. That's what they're doing. And that's because they cannot rationally explain with their equations how the universe works. That's why they had to invent all this nonsense.
I mean, on the one hand, I welcome this challenge, and I think that we are correct in questioning, all right, the relativity doesn't tell us everything, so we're missing something. And so I'm totally open to explorations. That being said, I will point out that you mentioned a 3D universe in your model. Well, 3D is like saying 3-dimension. This implies a certain spatial spreading. So your words, the semantics that you use, they imply mathematics. They imply the mathematics of maps in 2D and 3D space. And eventually they form a universe that is very much like what you would have in quantum field theory. Is there at the fundamental level a difference between what you say and quantum field theory?
Absolutely. I don't see any similarity at all. Quantum mechanics is based exclusively on discrete particles. The particles are not particles. The particles are not what any normal rational human being understands by the word particle. They're not corpuscles, which is what Newton thought about particles. They are fields, and a field is a concept, and a concept invented by Michael Faraday. It's a concept that means a region around an object. It's a region of values, of numbers followed by units. That's what a field is. There is no physical standalone object called a field, like there is no standalone object called a wave. The water waves, the flag waves, that's the object. What it does is wave. And likewise, you know, with a particle, if a particle is a field, then we don't have anything in front of us. There's nothing there. There's just values. And that's all math. And again, it's because the mathematicians have taken over, since the 17th century, they took over physics, called it mathematical physics, and all they do is math. And that's what they fed us in high school and college for centuries now. And people just started learning this stuff and saying, oh, science is math, math is science, physics is math, math is physics. No, one has nothing to do with the other because math only describes, physics explains. Physics has to do with qualitative explanations. Physics has to do with mechanisms and causes. That's the difference between math and physics. And until we get that, we see eye to eye on that, then, we're talking past each other.
Yeah, I think that it boils down to our original disagreement that physics must be about objects. I don't know where that comes from, but I'm willing to follow the path here. Oh yeah. Yeah, but I don't know. I don't know how you can compel me to want to see objects everywhere. To me, object is it's a very abstract term. Object can mean a lot of things. I mean, we can use it in the context where it means a physical object, physical matter, but object also in its more general semantic meaning, it means things that people can observe. It's like an object of a theory can be something that the theory is about. If my theory, for example, is about prime numbers, I could construct a series of mathematical equations that say, well, the number 7 will appear here and it's prime. We could say that the number 7 is the object of my theory. So I guess I would ask you again, I know that you did already, but how do you define objects?
Well, again, let me tell you what the problem with what you just said is, so that I clarify that first. And what it is that we have ordinary speech and we have scientific language. And people tend to bring words of ordinary speech, definitions of ordinary speech into science, and they don't realize how important the word is. And I'm saying if physics requires an object, which I do, you have to define what an object is. And I'm saying an object is not that which can move An object is not that which has volume, mass, not that which we can touch or see. Those are definitions of ordinary speech. In physics, we define the word object very stringently, very precise. And the precision is here. An object is only that which has shape. That includes, by the way, that includes two-dimensional objects and three-dimensional objects. Two-dimensional objects are objects that don't exist. Now we bring the word exist, which is really separate, is a separate word, okay? Exist is not the same as object. They're not synonyms. So there you have objects that don't exist, which are two-dimensional objects, you know, Bugs Bunny, Superman, tri-bars, those don't exist, but they are objects because they have shape. Then you have objects that, you know, that are three-dimensional, a table, a dog, a tree, and those are objects that can exist, not necessarily will exist, because the table I'm thinking about does not exist. So there's a difference. And for exist, we have to include the word location, but that's a separate issue. The point here is an object is that which has shape. And mathematical physics does not provide any object, any whatsoever, for any invisible entity. A wave is not an object. A space-time is not an object. A black hole is not an object because it's a zero-dimensional singularity. It's all mass and no matter. What else? Space-time is not an object. And so none of those qualify as objects for the purposes of physics. They qualify as objects for the purposes of ordinary speech and mathematics, but not for physics. Physics requires shapes. I have to be able to make a movie of my theory to explain a mechanism so that you understand it. Not that you believe it, so that you understand it.
I mean, if we were to take the black hole example, and I would tell you, black holes have shape. They're just not the singularity that is invoked in relativity. Black holes have a shape in that they are objects that have a structure whereby they will hide a certain amount of light, and they will let a certain amount of light pass at a certain distance from them. Isn't that a shape?
No, shape means it's got to I should be able to draw it. I cannot draw a zero-dimensional singularity. Remember what a black hole is or how it's formed. You have a star, three-dimensional star, right? That's the starting point. It's so big that it crunches, and crunches. It compresses all matter out of existence, all matter. There's no more matter inside a black hole. All you have is the word mass, which is a concept. And all you have is a singularity. And what is a singularity? It's a mathematical singularity, and it has no dimensions, no volume. You have all this mass concentrated in zero volume. That's not a physical object. That's the definition of nothing.
I mean, at this point, I'm wondering, do you believe in spaghettification?
I'm sorry, in what?
Spaghettification. Do you know that phenomenon whereby yes, things get stretched as they get closer to a black hole?
Yeah, but again, see, these are euphemisms. These are figures of speech that are introduced because, again, when you say, well, what is a spaghetti? And they'll say it's a one-dimensional line or whatever. And you say, hold it. You know, there's no such thing as a one-dimensional anything. I cannot draw one-dimensional anything. As soon as I put the pen on the paper or the chalk on the board, I already have at least two dimensions. No one can draw a zero-dimensional or a two-dimensional or a one-dimensional anything. A one-dimensional line, a zero-dimensional point. No one can draw this. Those are not words of physics.
I mean, I almost agree there. At least on certain points, I certainly agree. The thing is that we don't know exactly what is the limit of the resolution of the universe. That's how I would phrase it. It's like sometimes we may have objects that are so small that they are essentially smaller than the Planck length, and therefore you cannot tell that they have a dimension on the left or on the right of them. And that would be as far as our universe allows as being a line or being a line that is observable from a third-party observer. What's your point? What's your view on the Planck length?
Well, again, see, you're introducing first the Planck length is a mathematical concept. That's we're talking about length. Length is a concept. The second one is what you just said. You know, you're putting an observer. You're saying, how can I measure something that's so thin? Is it so thin that it becomes one-dimensional? And I'm saying, look, everything in the universe from here on out to the last bit of matter that you can imagine, everything is three-dimensional. There's no such thing as 2 dimensions, 1 dimension, 0 dimensions, 4, 5, 6, 7, 8, 26, and whatever dimension. There's only 3 dimensions. And anything outside of that is just mathematics and unimaginable. No one can imagine. Immediately, they have to do it by analogy. They say, look, you want to visualize 4 dimensions. Let me explain it to you. No, I don't want you to explain it. I want you to draw it.
All right, very interesting. So essentially, your physics is like
Rational.
what taxicab geometry is to Euclidean geometry. You start with an assumption about space, and that space is a constant thing, and it's just that the way it is, and that's how physics works. I'm interested. Let's get into the rope hypothesis.
Okay.
You present here. Can you tell us, in a nutshell, what is the rope hypothesis? I'm showing images of your video here. We see these ropes emerging from atoms.
Correct. What I'm saying is an atom is comprised in this way. Each one of those ropes that you see there, the red and blue ones, twined around each other. I'm saying that every atom in the universe is connected to every other atom. That means that if you were to look at any 2 atoms, they're connected by one of those ropes. As the rope approaches the surface of the atom, as you had it there, the ropes fork out. One goes into, the blue one there goes into the center of the atom. The red one goes around and forms the electron shell. So what you have is a star in the center, which we call the proton, and it's encapsulated inside this electron shell. That's the hydrogen atom in a nutshell. So that's
all right. And ultimately, the rope that you invokes are the equivalent in your physics of electromagnetic waves. Is that correct?
Yeah, because here, let me just really quick. Okay, here's a rope. Okay, and what I'm saying is, if you torque a rope, okay, if you torque it, I'm saying that torsion along a rope is what we call light or electromagnetic waves or whatever. I'm saying that the torsion moving along a rope is light. And one of the things that you can think about, if you take any rope, just take your grandmother's rope, okay, and you tie it across from one place to another, and you tighten it so as tight as you can, and you put two clothespins at each end. If you touch one clothespin, you'll see how fast light is, because that's how fast the torsion moves along a rope. The other clothespin moves almost instantaneously. You won't even notice how fast it moves. That's the fastest thing known to man. No device, nothing that man has ever invented travels faster than a torsion wave along a rope, a tight rope.
All right. Now you point out that there are, in the way light works, there are properties that are very much rope-like. And I found this fascinating. One of them is the fact that as wavelengths become longer and longer periods, the speed of the light remains constant, and it adjusts its frequency so that the speed remains constant. And that's what a rope does in the way it is wrapped around itself.
I'm saying that James Maxwell's equation, C equals frequency times wavelength, C being the velocity of light, 300,000 kilometers per second, is equal to frequency times wavelength. What are we saying? We're saying that if you increase the frequency, you must reduce the wavelength, and vice versa. Well, that's the equation of a rope. You take a rope of any length, a 1 meter length rope, two-strand rope, right, tied around each other. If you torque it more and more and more, the links become shorter, shorter, and shorter, and you have more links. So we have more links, frequency, and the wavelength has shortened, and vice versa. If you untorque it, now the links become longer, and you have fewer links. That's the equation of a rope that Maxwell discovered. C equals frequency times wavelength.
All right. And it's interesting how these ropes, when you think about them for the magnetic waves, how they interact with the atoms, because the atom is typically construed as a positive center, and there's an electron going around, orbiting around, or being there around in some probabilistic fashion. What you're saying is that at the entry of the atom, essentially, it is a division of the two mechanisms within your rope, the electric mechanism taking one direction and the magnetic mechanism taking another. Is that correct?
That is correct. The other thing you should keep in mind, you don't have it there in motion, but if you look at that picture, imagine that the red electron shell that encapsulates the proton. If that expands and contracts, if that gets closer to the center and farther away from the center, there, what you produce there, that is the famous quantum jump. By doing so, or quantum leap, by doing so, it torques the rope. And that's when we create the torsion along the rope that we call light or electromagnetic waves.
So to understand the quantum leap, and I'm not a physicist, I want to remind this to the audience, I am just a fan of everything science. To understand what the quantum leap is, it's kind of, you construe it as an uncertainty between where the border is into the wave, whether it's more in a red region or a blue region. Would that be a good way to understand it?
Well, I'm saying that what you have is this expansion and contraction. See, this thing moves back and forth. By doing so, that's the quantum jump. It's changing what quantum says energy levels. It falls to its lower energy level. By doing so, it emits one link of rope. And if you take all the links around, for every atom in the universe, around an atom, that's what we call energy. We have this energy expanding out of the atom, okay? And what it does is really torques the rope. And by torquing the rope, it sends a signal along each rope to every atom in the universe. That's why I can see you and you can see me instantaneously, because the rope connects us, simultaneously in both directions. It's a bidirectional system, whereas the famous wave and the particle, they're one-way mechanism. I can only shoot particles at you. I cannot, we do not receive the same particle at the same time. Whereas with the rope, by torquing the rope, we both see each other simultaneously.
Okay, so that would explain why a source of light goes in all directions from a center point, which would be the atom generating it.
Not only that, the moon can go anywhere it wants. There's a laser ranging experiment where they put a mirror on the moon and they allegedly shoot light at it, monochromatic light. They send a laser to the moon, but the moon moves. The moon is moving at 1 kilometer per second around the Earth. Okay, so the moon moves. Do you think they're going to send, the laser to where the moon is going to be in 1 second? No, they point the laser directly at the moon. Why? Because light is already connected to that mirror, to the atom that forms that mirror. And the moon can go anywhere it wants. It's never going to get lost because, again, the rope connects it at all times. You can send anything you want along a rope. If you and I are tied with a rope, you can move anywhere you want. I can send you torque signals wherever you are.
All right, now I'm going to try wrecking your brain. Can these ropes move faster than the speed of light? Do you think that if I have two atoms and I have one rotating around the other atoms at faster than the speed of light, would the rope sustain that kind of speed?
Well, no, I'm saying that you cannot travel faster than the speed of light, first of all. And you cannot because, Einstein was pretty much correct on that, and I'm not sure it was his idea, but the point is that no physical object can travel at the speed of light. Part of the reason for that is that imagine you've got the rope between two atoms, okay? One atom is approaching the other atom. It cannot go faster than the torsion along the rope that interconnects them.
So is it correct to say that let's try laying this out. As far as this theory goes for gravity, what is it saying?
Well, what it says is a picture is worth 1,000 words. I don't know if you saw the I sent you a picture and of gravity, and really it's worth 1,000 words, but let's see if I can explain with words. No, there's another one farther down, I think it is.
Okay. I don't, let me try to see if I can find it, but you can start explaining.
Yeah, essentially is if you have two objects, let's say the Earth and the Moon, okay? You separate the Moon from the Earth and you send it to the other side of the universe. Well, all the atoms of the Moon are connected to all the atoms of the Earth. There you go. The farther they're apart, okay, the more, like that picture on the bottom right there where you have the two little dots and they're separated by great distances, well, then all the ropes come together. They form like a single coaxial, and that's where gravity is very weak. As the two objects approach each other, the ropes begin to fan out because every atom is connected to every atom of the other object. As they're very close together, like in the bottom picture, you see that the ropes have completely widened out. They fanned out completely, and that's what causes acceleration of gravity. The more an object is closer to another, which is Newton's equation essentially, the more the ropes fan out, and that's what causes acceleration.
All right. Now, what happens with the sun? Because in the sun, the atoms are constructed in a form that we call plasma, and I guess that the electrons and the protons are free flowing. What happens to the rope in these circumstances?
Well, the ropes continue to maintain contact from one atom to another throughout the universe, no matter what happens inside the sun. You have to remember that you have, like, if you take an atom like hydrogen, it's different than an atom like in calcium. Calcium is element number 20. So it's got, you can think of calcium as being at least 20 hydrogen atoms. So each one of those components of the calcium will have one rope connected to it. You have to think of calcium as many hydrogen atoms. And what I'm saying, all hydrogen atoms are interconnected. So whether you form an atom such as uranium, which is 92, or an atom such as an element such as calcium, or one such as hydrogen, it doesn't matter. You have to simply count one rope per hydrogen atom.
But don't you consider that the sun is not made up of atoms, and that, yes, there may be atoms in the sun, but that the main part of the mass of the sun is a boiling form of matter that we call plasma?
Well, remember, because in this sense, I'm pretty much with quantum theory. I'm saying that inside the atom, inside the sun, we are squashing through pressure, right? Through pressure, we're squashing atoms and building higher level elements. So hydrogen turns into helium and so on down the line to carbon and so on. And so you're compressing matter. But when you do what you're doing is releasing thread. You know, they're releasing thread, and that thread that's being released, that's the so-called energy that we receive here on Earth in the form of high frequency along the rope. So you are releasing thread, right? And you are squashing atoms into heavier atoms, but the number of ropes remains the same. Nothing changed in the number of ropes.
Now I have some of the toughest questions. I think I'm gonna wreck your brain with these.
Okay, that's what I need you for.
Let me try to frame it correctly so that I'm reading Wikipedia here. All right. What happens if I create matter through matter creation? Is there a rope establishing from the new atom I've been creating to all the other atoms in the universe?
Well, what do you mean creation? You mean transforming, I guess, not creating. Creating, see, we have to separate these words again scientifically. People think that transform and creating is the same. Creating means that you create something from nothing. What God did with the universe. He took empty space or vacuum and turned it into some physical object. That's creation. Otherwise, we have transformation. We transform a tree into a table. That's transformation.
Well, I'm looking at matter creation here on Wikipedia, and again, not being a physicist, it seems that you can collide photons and create matter from it.
This is the issue. The issue is that quantum mechanics and general relativity have become creationist theories. In the case of general relativity, we have Big Bang. that from Big Bang they created matter. You know, matter was created from nothing. In fact, I have here a comment, if you allow me to read it, from Mr. Stephen Hawking, who died recently. And he says how the universe came to be. In other words, how matter came to be. And here this really underlies my argument of why we need objects. And he says, at the Big Bang itself, the universe is thought to have zero size. There are something like 10 million, he gives a big number, right, of particles in the region of the universe that we can observe. Where did they all come from? The answer is that in quantum theory, particles can be created out of energy in the form of particle-antiparticle pairs. And he continues, but that just raises the question where the energy came from, right? Okay, good. The answer is that the total energy of the universe is exactly zero. The matter in the universe is made out of positive energy. Now, twice zero is also zero. Thus, the universe can double the amount of positive matter energy and also double the negative gravitational energy without violation of the conservation of energy. In other words, these people, the first thing is that Mr. Hawking needs to understand. I guess we get erased there?
No, I'm still there. You may not see me, but I'm there.
So the first thing we have to understand, energy is a concept. And what Mr. Hawking is saying is that the universe, matter, was created out of a concept that humans created. He's saying we got energy. What is energy? Energy is a concept. It's an undefined concept because we have Mr. Richard Feynman, who says, by the way, no one knows what energy is. So we don't know what energy is because it's not is a something. It's a concept. And from this concept, according to Mr. Hawking, matter came into being. Self came in without God. You know, this was done all by itself. So they have a creationist theory. And then the quantum has a creationist theory because they say, look, you take two photons, you smash them, and you create particles. What are these particles? They're virtual particles. They last for a single second to make our equations go right, and then they go back into being empty space. And so this is all magic. This is not a rational explanation. And what I'm saying is what these people are saying is a photon is simply the effect that the rope has when it meets an atom. You know, if you torque a rope, you're still pushing on the rope, and that little nudge that it gives the atom, that's what they identified as a particle. So yeah, we're creating matter, not because we're creating it, but because we're detecting matter when we strike a photon against an atom. That's what's happening.
All right. Now, what happens to the places in the universe where there's no matter? Can these ropes exist? Could they exist and be sent to no one? Because it seems that in your model, there's always two atoms or two pieces of matter that are linked by a rope. What about sending a rope where there is no matter?
Well, you can't send the rope. Remember, the rope connects two atoms, so the rope doesn't go anywhere. The rope just torques. What I'm saying is that, you know, you have, wherever you have matter, wherever you have atoms, well, that atom is connected to another atom in some other part of the universe. They're all interconnected. But so in a region where there are no atoms, there are no ropes. In a region where, you know, where you have empty space, vacuum, total vacuum, because space is not a physical object like it is in mathematical physics. They say they bend space, they bend time. You can't bend the vacuum. And so they had to convert space into a physical object. That's why they talk about three-dimensional space. And I say that's irrational. Space is not three-dimensional. What is three-dimensional is the object, not space. Space is nothing. And so
but suppose I look at the sky, okay? I look at the sky at night, and I find a spot that's very, very dark. And I zoom on it, and I ensure that there's really no star in that direction. And I zoom, and I zoom, and I zoom, and I get to a point where I'm absolutely sure this is empty space there. You're saying
Correct.
that if I send a ray of light that way, there's no ray of light because there's no rope.
You got it. Yeah, there is no ray. You can't see. That's why you can't see it. Why can you see the Andromeda Galaxy? I mean, you can see the Andromeda Galaxy because the entire galaxy has one coaxial tied to your eye, at least.
But do you know what the crazy?
Let me put it in these terms. You need a highway in order to send a car. And what these people are doing, they're saying, look, we don't have a highway. We just have the car, and we're just going to send it out there. No, you need a highway. And I'm saying the highway is the rope. Light goes along ropes, a torsion that moves along a rope to your eye. That's the reason you can see the Andromeda Galaxy. It's not because they're sending little particles called photons, which are not really particles, not corpuscles. They're fields. And these fields are also waves. Whenever the mathematician wants it at his leisure, he says, well, now it's a wave, and now it turned into a particle. And is it a particle? No, it's a field. What is a field? It's just a bunch of numbers. So they don't have any physical object at any point. I'm saying, no, there is a physical object. That object is a rope, and the so-called light is the torsion. What is gravity? A whole bunch of ropes connected from one object to another.
But
so
that means
we can make sense of the universe.
If I stand in space and I have a ball of light, it sends light everywhere.
Yeah.
You're telling me that either the entire universe is stuck in a shell of matter that allows ropes to be sent in all directions, or that there is some spot in which the light is not emitted.
There's some areas where light is not emitted simply because there's no matter, no atoms in that region. Like if you take, I'm convinced that if you take two galaxies, the region between the galaxies is so devoid of matter. Maybe there's some interstitial gas out there floating around, but in general, you can think of that region as just devoid of matter. There are very few atoms comparatively. And yes, in that region, we can't see anything between two galaxies because there is not enough matter to see.
But here's how I can take this statement of yours and make it violate the principle of energy preservation. So
conservation of energy,
yeah,
you mean?
Conservation of energy. So I'm holding that ball and I'm in the universe. Therefore, there are spots where light is not going, and therefore there are spots where I'm not losing energy. Now, what if I build a little shell, let's say 1 kilometer out of that ball, I build a full shell that encompasses the entire system, such that now light can be emitted at every point. Your prediction would be that if conservation of energy is a thing, then there are some points of light that will be emitting stronger light suddenly, because now there's more energy to be released, because in the shell there is less energy to be released on every point, because the energy is more divided across a full 360-degree system, whereas in the universe there were spots where it was not going.
Let's see if I understand you correctly. Are you saying there's in your hypothesis, in your assumption, you're saying we're assuming that there's a shell that encompasses all of matter?
No, what I'm saying is, let's think of an experiment. On the one hand, I have a ball of light and I'm emitting a certain amount of light in empty space, and it's going, some of it is bumping on galaxy, and there are some places in the universe where it's not going because there's no mass. Now I'm saying, do an experiment in which you do that, and then add a shell of matter, maybe 1 kilometer away from that ball, a full shell that makes it such that there is mass everywhere around the ball. Now suddenly what I should have is that, because the light is more divided, because it's going in more directions, I would have to have a decrease of the energy released at any point in space from that ball of light.
I'm trying to understand what you're saying here. If there's a bit of matter out there, a shell or whatever, a blob of matter, it's made out of atoms. And if it's made out of atoms, it's got each atom that you have in that shell is connected to whatever you're reflecting light off of. So if I send light, in other words, I send a torsion, not energy, because there's no such thing as energy. Again, until someone defines the word energy, we can't use that word. We can't use the word mass. That's undefined as well. So we can only use objects. And I'm saying if you send a torsion along a rope, in other words, you torque the rope, right? That signal arrives in the Andromeda Galaxy, which now sends that same signal to another bit of matter, which you just created there. Okay, you created some bit of matter made out of atoms. Then it's just going to receive that signal. It's going to receive that reflection of that signal.
I want to be clear, so I'm going to make a drawing of it, because here it's the most artistic show on the internet. We don't care about taking the time. So, because I think you don't catch my full experiment. So I have situation 1. We will call it 1. I have a ball of light. It's emitting light. and I put it in empty space somewhere in the universe, and there are galaxies here. Let's label them as G, galaxies here.
Okay.
And there are some spots where light cannot go because
Correct.
there's no mass this way. There's no rope that can be established that way. Would you agree with that?
Yeah, so far so good.
All right. So therefore, if I have an observer that stands between a galaxy and this, the observer will be able to quantify that a certain amount of light at a certain frequency that is holding, in classical physics, that is holding a certain amount of energy, that some light is passing here.
Yeah.
And of course, I won't be doing the stupid version of my hypothesis would be to say, Bill, what if an observer looks at this ray of light? This ray of light doesn't exist because there's no mass here. There's no galaxy to be receiving the rope. But the observer, by standing in the way of the light, would obviously be ruining the experiment. So here I'm suggesting a second version of the experiment in which I have the same source of light with the same amount of watts. Let's say that it was powered by a 120 watt apparatus of some kind. So I have the same amount of watts, it's the same apparatus, but then I took the time to build a 1 kilometer wide shell around this light source.
Okay,
1
what is
kilometer.
that shell made out of? What is the shell made of?
That shell is made up of, let's say, rock.
Okay, atoms.
Yeah, atoms, absolutely.
Okay.
Now I have the same thing. I have this source of light. It's sending light everywhere. However, this time, there is no spot at which ropes cannot be established. What I'm telling you is that the prediction of your model would be that, therefore, the rays of light that I detect here would be lower energy.
Why would they
would be lower energy? Because the same source of light here is sending to more directions than it was in situation number 1.
Well, it's not that it's sending in more directions. It's sending to the atom that's building the shell. In other words, each rope sends its own little torsion. So it depends on how many atoms you've got in that shell. You know, from one atom in the source to the atom in the shell, it sends along a rope a given signal. Nothing changes in the so-called energy. But again, we need to know what this word energy means. Until then, nobody can use the word energy.
All right. Well, I think I'll leave it there, and I will let our audience maybe come in the comment section and tell me, what do you think would happen? Would you predict the energetic measurement in my experiment to change or not to change? Those are all interesting considerations. Now, before I think we can look at the reactions of the crowd. Andrew J sends $20. He says, I was just going to ask about gravitons. Thanks, JF. Dame Wingate says, JF, I'm celebrating my 10-year anniversary with my husband today. He introduced me to your show and book. Please wish him happy anniversary. I wish your husband happy anniversary. I'm happy that you guys are in a 10-year marriage. That's about 10 times the duration that my marriages survive. I was talking about this with Bill before the show. He was like, you've been married 3 times, Jeff. Yes, women tend to leave me.
Conservation of energy.
I have not found my own way to build a shell 1 kilometer around a woman so that she would stay at the center point and preserve energy with me. Not JF says, but what if a concept makes us able to predict an outcome? That is a question to Bill. So what if the concept helps us predict stuff? It is a scientifically valid concept to some extent, isn't it?
No, because again, we don't do predictions in science. That's in mathematics. In the religion of mathematical physics, they do predictions and they brainwash the world after so many centuries that predictions are an important part of science. No, predictions are an important part maybe of technology, which again has nothing to do with science. Science is only about explaining a phenomenon. We do not do predictions. It's astrologers who do predictions.
All right, wonderful. Andrew J said,
"If they predict wrong, they're executed."
Andrew J says, motion is a concept itself. Do you believe motion doesn't exist? And I think you have a video about this, Bill.
Well, we have to look at the word exist, because the word exist, people never defined it. No one in 10,000 years defined what exist means. That's why people talk about the existence of God or the non-existence of God, because they never defined the word exist. And I did define the word exist, because physics is the science of existence. Physics studies only that which exists.
All right. Machiavelliscus says...
So to say that motion exists is wrong. That's okay in ordinary speech. In science, we cannot say that motion exists. Only objects may exist in physics. So concepts do not exist. Love does not exist. Motion does not exist. Space-time does not exist. Black holes do not exist, because none of those are physical objects. Only objects may be said to exist. An object that has location is an object that exists.
All right.
So if God wants to exist, he has to first be an object. He cannot be a concept. Is God a physical object, or is he an abstract concept? Is he a human with a little magic wand, or is he love? Is he intelligence? That's concept. So God cannot be both. God is either an object or a concept. And then if he's an object, if God wants to exist, he's got to have location. There's got to be distance between my chest and his. Otherwise, he doesn't exist by definition.
All right. Andrew J says, no, Machiavelliscus says, is time travel possible?
In the religion of mathematics, yes, but not in science.
All right. Not JF says, can Bill's physics tell me how much force and fuel I need to send a rocket into space?
It's not a question of science.
Yeah. It's a pragmatic question of application.
In physics, we do not use mathematics. In physics, we have to explain a phenomenon. We have to explain something as simple of how a farmer pulls on a donkey. And the way you explain it is you say you tie a rope around the donkey's neck and you pull on it. That's how simple physics is. Physics is for kids, for babies. It's kindergarten stuff. Once you make the invisible objects visible, it's kid stuff.
Incredibly offensive.
I can give you an example, for example, so that you understand my frame of mind. Doesn't mean you have to agree with me. I'm just saying this is my frame of mind. Here you have a farmer pulling on a donkey, right? And he pulls, he's pulling on the donkey, and the donkey comes forward. It turns out that you cannot see the rope with which he's pulling on the donkey. And you say, well, how did you do that? By magic? And the farmer says, well, no, see, the rope has ultra frequency, high frequency. It has, it's in the ultraviolet range, and that's why you cannot see the rope. So until you can see the rope, it's magic. And you say, oh, it was mass, it was energy, it was force. But as soon as you see the rope, you say, oh, that's simple. He pulled on a rope, and that's how he pulled the donkey forward. And what I'm saying is what we have to do is make the invisible objects visible. If there's a magnet that attracts another magnet, there's a physical entity between them. You cannot use the word energy. You cannot use the word force. You cannot use the word field. You got to use a physical object. There's something there that we cannot see, we cannot touch, that's producing that physical effect. And until we make it visible, we won't understand. We will not have a physical interpretation of how two magnets attract each other.
All right. Incredibly offensive says, how can you say waves are concepts? Haven't you ever used a microwave or a radio?
Yeah, I use a microwave because a microwave is a physical object, the oven, right? But a wave is not a physical object. They made people believe that, the flag is a physical object, not the waving of the flag. Water is a physical object, not the waves that brush, that move along the water. Wave, there's no physical object called wave. You go to the hardware store and you ask them for a rope, they'll sell you a rope. Ask them for a wave, let's see what they sell you. Ask them for a field, let's see what they sell you. Ask him for energy, let's see what he gives you.
All right. Jan Camarillo says, is the rope connected to time in any way?
Time is not a word of science. Time is a word of religion. So we don't use that word time for anything. We have no need for time because time only describes, energy only describes, mass only describes. In science, we do not describe. In science, we explain. You have to explain a mechanism. So we do not use the word time. I cannot attach anything to time because I cannot attach anything to love or to intelligence. There's no physical object called intelligence. There's no physical object called time. But we have been brainwashed so much with these words that we treat them as physical objects. People think that energy is a physical object and it turns into mass, which is a physical object. And they're all concepts, mathematical abstractions.
All right. Well, I mean, time has to exist in some way, even if it's not an object, even if you can't play with it in the universe. It has to be a proper description of what happens when you move objects, doesn't it?
When you say that time exists, you have to define the word exist because that makes or breaks your argument. What do you mean by exist? And I'm sure no one can define it because no one has done it in 10,000 years.
Yeah, it's a very hard question. What does exist mean in the context of time? I would say it is a phenomenon from which I can see I can see something emerging from it. Like,
not in the context of time. What you have to tell me is a definition that you can use across the board. You can use for
I would
time,
say that
you can use for tree, you can use for everything, for God.
I would say I cannot construct a view of the universe that doesn't invoke time in some form. There is this dimension across which we are moving as 3D objects, aren't we?
But what are you using time for? To describe? I mean, what is a second?
Yeah, I mean,
scripture.
It is clearly a dimension of the universe. Would you agree with that at least?
No, it's not a dimension. Dimension, there's only 3 dimensions, length, width, and height. Time is a coordinate. In fact, it's not even a coordinate. Time is a number line. Time is a number line.
Absolutely, I agree with this, because we're walking along it in a unidirectional fashion.
Time does not have any importance in science because time is only used to describe. At first, it's an undefined word. Nobody has defined the word time in 10,000 years, so they cannot use it until they define it precisely. I have defined time, but they got to read my book for that. No one has defined time in mathematical physics. No one has defined it. But assuming they did define it, it's a concept. And it's not a dimension. It's not even a coordinate. All that time is a number line. It doesn't have direction, which number lines don't have. And it has magnitude, which is what number lines have. A dimension is something else. Dimension has to have 2 properties, orthogonality and direction. And time has neither one of those. That's why time is not a dimension.
All right. Polymatic Need says, Jeff, ask him about quantum entanglement. Do you have any take from your theory on entanglement?
Perfect. I'll illustrate it for you.
All right.
I'll illustrate it for you, okay? Here we have it, okay? Let's see if I get this right. Let me get it right here. Okay, there we go. I think, what can I do this? There we go.
Okay.
I guess it's that way. Okay, you see that? Now, I'm going to twirl the rope, okay? From my end, it's twirling counterclockwise. How about from your end? Can you tell me from your end how it's twirling?
It's like a rotation clockwise.
Clockwise. Okay, now I'm going to turn my rope clockwise. How is it turning on your side?
Counterclockwise.
Now you have a definition of entanglement. When you take a reading at one end, you're going to have the rope go clockwise. The other end cannot avoid going counterclockwise. When you turn the rope clockwise, the other end must turn counterclockwise. Period. We're done with entanglement. Very easy stuff. Kid stuff, baby stuff.
Very interesting, because I was about to ask more generally. The rope has a structure whereby if you take consecutive slices of the rope, the red and blue parts of it are rotating. What does it manifest itself into in our universe if there are ropes that do carry the light signal?
I didn't get the question. What does what?
Let me draw it here. I'm gonna erase this, my old drawing. So essentially, you have, if you cut a rope, you have a red part of the rope that will appear to be a certain part, and you have a blue part of the rope that will appear to be another part. Now, if I cut it at a different place along the rope, the blue part will be a little more rotated as opposed to the red part being at another place, depending on where I am in the rope. How does this manifest itself in physics?
In other words, if you go along the rope is structurally torquing already. It's already twisting around each other. The rope is DNA. Just think of DNA. What is DNA? DNA is a rope, and that's where DNA got the idea from light, because light is already a torsion. If I take a cross section of the rope, if I could cut it, you can't cut it, but assuming I could cut it, what I would see is two threads. And yes, anywhere along the rope, you're going to have, a total switching of the sides of one thread with respect to the other. There's going to be a torsion there, a structural torsion, by the way. Aside from the fact that the rope also rotates, because when you pull on two strands, it torques the rope automatically. And that's what I'm saying light is.
Wonderful. Why am I sends $10? He says, Jeff, thank you for writing the revolutionary phenotype. I have a copy under the Christmas tree. It's been a great year for the public space, and I want to thank everyone for stopping by. Hope all is well. Indeed, I'm very proud to have such a dedicated fan base who have made my book rise to the top of the Amazon biology section. Thank you so much, and keep buying it, keep spreading it, buy a copy for your friends. It's an important book. Corey Muldoon says, a black hole is just a neutron star you can't escape. All right, that is a good shower thought. Martino Giofrada says, gentlemen, is not energy ability to do work, and is not work force multiplied by distance, as we all learn in university? So I think he's getting at the definition of energy, right?
Yeah, but again, if you define a word, it's obviously not a physical object. In science, in physics, we do not define objects. We point to them. You say table, you point, and the extraterrestrial understands the word table. And you can't do that with concepts. I cannot point to energy and say, this is energy. I have to define the term, and that's why he's defined it. And how did he define it? He defined it mathematically. He's defined it in terms of work, distance, or whatever. But again, then you have all kinds of energy. You have potential energy and, dynamic energy. You have all these types of energies. And then you have Mr. Feynman says, oh, by the way, we don't know what energy is. So they're using a word that they can't define. And they're using that to say, well, the conservation of energy, and energy turns into mass. And for everything, we put the word energy. Why don't we put the word spirit? I like the word spirit, not the word energy. It's a better word. The spirit did this. I transferred the spirit. Is spirit a better word than energy?
All right. I think that we are headed toward a conclusion, because I have another guest who's coming in 7 minutes. He wants to challenge me on my book and the scientific theory on it. Perhaps I would explore one last question with you, because
yes,
when I look at your model, I think it's a great model, and it stimulates the mind, certainly, to try to understand the universe in simpler terms. And I love it. I love that a lot of the characteristics that you identify they seem to be matching the mathematics of a rope. But then I would ask the question, isn't it better to just think of the universe as fields, as quantum fields? And isn't your theory ultimately isomorphic to quantum fields, whereby if I give a property to every point in the universe, as is done in quantum field theory, there will be the possibility of an establishment of a rope-like entity between atoms, between different parts of the universe that send either gravitational or light signals or forces or whatever we want to call them. Ultimately, is your theory making any prediction that quantum field theory wouldn't?
We don't make predictions. First of all, we only explain. That's the first answer to that question. We don't. Predictions is what they do in astrology and mathematics. We don't do predictions. That's the first one. The second one is that, again, until we know what a field is, we don't know what we're talking about. And no one has been able to define the word field except Mr. Michael Faraday and James Maxwell. They defined the word field, but everybody forgot what they said. There is no such thing as a field. I cannot bring a standalone field and put it in front of you. I cannot take the magnet out and leave the field and say, here's a field. There's no physical object called field. The word field means region around an object where there are values. That's what the word field means. And so then we have that problem. And no. So I don't use the word field at all, except to relate the rope to what mathematics has as far uses the word field for. So I'm saying when they say field, this is what they're referring to in terms of ropes. When they say energy, this is what they're referring to in terms of the rope model. And so I make that's the only time I use the word energy or field, just to show what people are talking about. But in mathematics, you don't have a standalone field, you don't have standalone energy, you don't have standalone mass. These are concepts, and people have turned them into objects and they treat them as objects. And that's why I'm saying every time you use the word energy, mass, field, just put the word spirit and you'll be okay.
All right. Well, Bill, it was really a pleasure talking to you. I really love your defense of your ID. I may not fully adhere to it, but I'm thinking there is a geometrical thinking there that this theory stimulates inside me, that even if it was only to make me review eventually some of my preconceived notions from being raised through relativity and quantum physics and Newton mechanics, I think that it certainly has a very stimulating effects on the mind. And even if it was just for that, it would certainly have a great value. I thank you so much for coming tonight.
Well, thank you.
All right. Have a great day.